Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 889. Please turn to it, page 889, and today is our lesson number 123. This is the beginning of the gradient questions. There are 10 of them. Beginning with question number 9, there are 10 of them. The first two that you see on the first page, they are easy. On the following page, there are 4 of them. They are medium. And on the last page, on page 891, there are 4 more, and those are hard. Keep it simple. Just think of these questions in terms of pages. Don't worry about the exact location. The first page is easy, the next page is medium, the last page of the gradient question is hard. Number 1. So number 1 that we're going to do, question number 9 that we're going to do on a scale of 1 to 10 is number 1, because there are 10 of them. An hour-long television program included 20 minutes of commercial. The question simply is, what fraction of the hour-long program was not commercial? Pay attention, that's the only thing. The only reason you will get this wrong is because you're not paying attention. You're making careless mistakes. They're not asking what fraction of the hour-long program was commercial. It says what fraction was not commercial. So 20 minutes of commercial, which implies that 40 minutes is not commercial, and the answer is 40 over 60, because it's an hour-long program. 40 over 60 is the answer. Divide top and bottom by 10 and you end up with 4/6. You can grade this in as 4/6. It'll be accepted, it'll be fine, or you can reduce it to 2/3. Either way is fine. Number 10. The rule for the gradient problem is that as long as you can fit your answer, the computer will accept it. It doesn't need to be reduced. And if you look at the top of the page there, on page number 889, they give you a sample of that. There are 4 spaces for you to grade in your answer, so you could very easily grade in 4/12 if you wanted to, if you didn't want to reduce it. If the product of 0.3 and a number equals 1, a product of 0.3 and a number, let's call it x, equals 1. What is that number? Well, let's something have to solve for x. The very first thing we're going to do, I hate dealing with decimal, as you know by now. If you've been watching my videos, you know I hate dealing with decimals. I detest decimals. Let's multiply both sides by 10 so that we can get rid of this freaking decimal. Now 10 times 0.3, we simply have to move the decimal point to this side and it becomes 3x. 3x equals 1 times 10, which is 10. Therefore x equals, divide both sides by 3, and x equals 10 over 3. That's all. Again, don't waste your time trying to be fancy with the decimal and all that. Leave it like that. Just grade in 10. Just grade this in as 10/3. That's all. You have 4 spaces, and you 1, 2, 3, and 4. One space will be taken up by the slash sign here, and you'll be fine. Do you understand? Don't make your life unnecessarily miserable by trying to be fancy. As I said, don't try to do 3.33. It's not necessary. Number 11 on the next page, page number 890. We are told that when we see this symbol here, a triangle with x, y, and z, we are supposed to follow certain instructions. That's what it is. These type of questions are set of instructions. What are the instructions here? The instructions are, we are to take the number that we see on the left-hand corner and raise it to the number that we see on the top. And then from that, we have to subtract the number that we see on the right-hand corner raised to the number that we see on the top. Those are the instructions we are asked to follow. So we're going to do that. The question is, what's the value of 10, 3, and 5? Well, in this case, our x equals 10, our z equals 5, and our y equals 3. And we're just going to follow the instructions. So it becomes the number on the left hand side. We are supposed to take the number on the left hand side, which in this case is 10, and raise it to the number that we see on the top, which is 3, minus the number that we see on the right hand side, which is 5, and again raise it to 3. And all we have to do now is to figure out what that is. So let's do it then, shall we? So this guy is simply 10 times 10 times 10, 10 times 10 times 10. I don't know why I'm doing it out, I feel silly. And 5 times 5 times 5. 10 times 10 is 100, 100 times 10 is 1000. So this is 1000 minus 5 times 5 is 25, and 525 make 125. Minus 125 is our answer, whatever that happens to be. 1000 minus 100 would have been 900, and therefore 1000 minus 125 should be 875. 25 less than 900. That's it, that's your answer, 875. Number 12. Number 12. In number 12, we are given a picture and we are told that it's not drawn to scale. Alright. In the picture above, PQST is a rectangle. So we're going to draw PQST. PQST. PQST is a rectangle. URST is a square. Where is URST? URST is a square. URST is a square. Alright, so far so good. We are also told that P to U is 5. P to U is 5. And since this is given, this is not going to change, this is fixed. Since this quantity is fixed, I put a box around it to remind myself that that 5 is something that we did not plug in. It is given to us, it is fixed, we cannot change it. We are also told that U to T is a positive integer. This distance here, U to T, has to be an integer. The fact that they tell us that it's a positive integer is a moot point because it's it's the length of a side. A length of any picture cannot be a negative integer. When was the last time you saw a rectangle with the length of -5? Obviously it's positive. But the point here is that it has to be an integer. It has to be a whole number. What the hell are they asking? If the area of PQST is more than 10, alright, so area of PQST, right here is the PQST, and we are told that the area of this guy, is more than 10, but less than 30. What is one possible value of U to T? This is what we're looking for, U to T. One possible value of this guy right here. Let's find out, shall we? What happens? The area of PQST equals the length of P to T, times the length of S to T. Now keep in mind that we are told that URST is a square, which means all of these sides are equal to each other. All of these sides are equal to each other. And now I put those dots there. It's a square. One more time. The area of the rectangle PQST equals the length of P to T times S to T. In other words, length times width. That's what it is. That's what this is. Now what can we say about P to T? P to T. We know, okay, listen very carefully. We know, I don't know why I keep saying that, because this is the habit from teaching in the classroom, because even if you didn't listen carefully, you can always rewind it. And I know that. It's just a force of habit. Where was I? U to T, keep in mind, has to be a whole number. It has to be a whole number. Let's try putting in 1 here. If U to T happens to be 1, listen very carefully. Oh, there we go again. If U to T happens to be 1, in that case, P to T will be 5 plus 1, which is 6. And S to T would also have to be 1. Why? Because URST, we are told, is a square. So if if we're going to pretend that u to t is 1, then this side will also have to be 1. So the area of this rectangle PQST will be 5 plus 1, which is 6, which is p to t, times 1, which is 6 times 1. But 6 times 1 does not work out, because 6 times 1 is just 6, and we are told that the area of this guy is more than 10. This is not more than 10. This does not work out. Let's try putting in 2. If we're going to pretend that u to t is 2, because it has to be a whole number. We tried 1 was too small, it wasn't working out. If u to t is 2, in that case, now p to t would be 7. And s to t would have to be also 2. Again, because of the fact that u, r, s, t, we are told, is a square. So now we have 7 times 2. 7 times 2 is 14. 14 falls between 10 and 20. That does work. This part, this one works. Let's see if we can make it 3. If we're going to pretend that u to 2 is 3, as far as the exam is concerned, we are done. As far as the exam is concerned, we are done. Because they're asking us what is one possible value of u to t. We just found out u to t could be 2. We just saw it a second ago. This extra part that we're doing is only for the learning purposes, because they're asking us what is one possible value of u to t. That makes me wonder how many possible values are there. Let's do all of them for learning purposes. But as far as the exam is concerned, we are done. One possible value is 2. Is 3 possible? That's the question. Is 3 possible? Now if u to t happens to be 3, in that case p to t would be 5 plus 3, which is 8, times s to t, which will also have to be 3, again for the same reason that it is a square. 8 times 3 is 24, and 24 is more than 10, and it is less than 30. So that also works. That also works. Let's try 4. If u to t happens to be 4, then p to t would be 9, and s to t would also have to be 4, because of the fact that u, r, s, t is a square. And now we'll have 9 times 4. The area of the rectangle PQST would be 5 plus 4, which is 9. 9 times 4, which is 36, and 36 is not less than 30. That does not work. So the question was, what is one possible value of u to t? 4 does not work. 4 does not work. We found out that 2 works and 3 works. 2 works and 3 works. Right here. 2 works and 3 works. So there are 2 answers here, 2 or 3. Which one do you grade in? Don't try to be fancy. Don't grade it as 2/3. That will be silly and idiotic, because the computer is going to read that as 2/3, not 2 or 3. They're asking for the one possible value. Just give them the one value and get the hell out of there. Just grade in either 2 or 3. That's all. That's it, we're done. Next one, number 13. Number 13. Number 13 says, a company sells boxes of balloons, well, good for them, in which balloons are red, green and blue. Red, green or blue. I don't know why do they have to come up with these annoying names that one doesn't know how to pronounce. Luan. Purchased. In the previous exam we came across Ahmed. Luan purchased a box of balloons in which 1/3 of them are red. Alright? 1/3 of them are red. If 1/3 of them are red, which means green plus blue must be 2/3. So far so good. If there were half as many green balloons in the box as the red one, there are half as many green as red. Well, that implies, because of the fact that we are told that red is 1/3, that implies that there are half as many green. That implies that green must be half of 1/3. half of 1/3 is 1/6. The green must be 1/6. So we're going to put that here now. Now that we know that green is 1/6, we're going to put it underneath green. Green is 1/6. Let's keep reading. And 18 of them are blue. 18 are blue. What the hell are they asking? How many balloons are in the box altogether? They're looking for the total number of balloons. So here's what's going to happen, okay? I need the room. We're done with this part. Half as many green as red, which implies that green must be half of 1/3, which is 1/3 times half, which is 1/6. So the green is 1/6. We're done. I need the room, so I'm going to get rid of it. Now what we have to realize is that in order for us to compare the fractions, this one has a denominator of 6, this one has a denominator of a 3, so I'm going to multiply the top and bottom of this guy by 2. And hence making it 1/3 is same as 2/6, which makes perfect sense. Nobody's going to argue with it. So the red is 2/6, the green is 1/6, 2/6 plus 1/6 is 3/6, 3/6 is half. That tells us that 18 represents half of total. If 18 represents half of total, that implies that total must be 18 times 2 or 36. That's all. That's it. One more time if you like. Here's what happened. We were told that there are 1/3 red. But if there are 1/3 red, and then they go on that the green is half as many as red. If red are 1/3, then green would have to be half of red, which is 1/3, or 1/2 times 1/3, which is 1/6. Right there. If these are 1/6 and these are 2/6, because 1/3 is same as 2/6. If these are 1/6 and these are 2/6, 1/6 plus 2/6 is 3/6, which is 50%. Half the balloons in the box, they're telling us, are either red or green. If half of them are red or green, the other half must be the blue, which we are told are 18. So 18 represents half of the total. If 18 represents half of the total must be 2 times 18. That's all. Number 14. You're done with this one? Number 14. The last one on the page. 3 points P, Q and R lie on line L. Alright. So here's our line L and we have 3 points P, Q and R. They do not tell you exactly where, so we can put them anywhere we like. 4 distinct points S, T, U and V lie on a different line that is parallel to L. So let's draw a parallel line. I'm going to call it M, and there are 4 of them. S, T, U and V. So far so good. You must draw the pictures when you're doing the problem. Don't just read the freaking thing. You must draw it, understand it, absorb it. Do it actively. Lie on a different line that is parallel to L. Alright. What is the total number of different lines? Let's read carefully. What is the total number of different lines that can be drawn so that each line contains exactly 2 of these 7 points? So we're going to draw lines that contains exactly 2 of these 7 points, and the question is, how many lines are possible? Well, let's find out, shall we? Well, if we were to start with point P, we can draw from P to S, or we can draw from P to T, or we can draw from P to U, or we can draw from P to V. 1, 2, 3, 4. What the hell? That's not a point. That's a line N. That's it. There are 4 of them. You get the idea. Similarly, if you were to start from point Q, we can draw from Q to S, or we can draw from Q to T, or from Q to U, or from Q to V. And finally, if we were to start drawing line from point R, we could draw from point R to S, or R to T, or R to U, or R to V. How many lines do you see there? I see 4 black lines, I see 4 blue lines, and 4 red lines. 4 plus 4 plus 4 is 12. But this was a very long, very tedious, and very babyish way of doing the whole problem. The quicker way simply would have been to realize there are 3 of these, and there are 4 of these. There are 12 ways we can combine them. That's all. There are 12 possible lines that can be drawn. I was about to give you the letter for the answer choice, letter A, B, C, or D, but I just realized it's not a multiple choice question. The answer is 12. That's what we have to grade in here. Alright? I will see you tomorrow. Okay? Bye now.